Welcome to In 5 Minutes. Let us discuss the second type of multiplexing, which is called time division multiplexing. So the purpose is still the same. We have multiple signals to be transmitted in the form of one composite signal. This time, instead of dividing the frequency scale into individual slots, we are going to divide the time scale or the time axis, and we will achieve time division multiplexing. Let's take an example and try to understand that. So let's say, for example, we have multiple signals starting from 1 to n to be transmitted. So the signals are available on this particular transmitter lines. There is a switching device on the transmitter side. This switching device in technical terms called commutator. So what this commutator will do, in the very beginning, the switch will be connected to the first input channel, and it will read a sample from the first signal, and that sample will be transmitted to the communication channel. So this is common communication channel that we have once again. So let us keep on drawing how the signal will look like with respect to time t. So the very first sample that we have taken is a sample that is coming from signal number 1. So I'm going to call it S11 because that's the first sample of the first signal. Afterwards, this switch will move from first input channel to the second input channel. It will read one sample from the second signal now. So afterwards, the second sample which will appear on the communication channel, I can give it a name of S12 because that's first sample but of the second signal. Similarly, the switch will go through third, fourth, fifth input channels, and likewise it will reach to the last input channel. It will read a sample from that input channel, and let us say that last sample is called S1n. 1n because it's the first sample of nth signal, and in between there will be samples coming from various intermediate signals. Now after the switches reach to the last input channel, it will now go back to the first input channel, and it will read the sample from the first signal this time. So it will again transmit sample from the first signal, the red sample, and now this time this sample will be called S21 because it's the second sample of the first signal. The switch will then move to the second input line, and to the second input line it will again read one sample, and this sample will now be called S22 because it's the second sample of the second signal. And likewise it will go through all the signals in between, and when it reaches to the last signal, it will again read one sample from the last signal, and this time this sample will be called S2n because it's the second sample of nth signal. Likewise, the switch will keep on moving across all the input channels, and it will keep on reading samples from all the signals. So now how are we achieving multiplexing in this case? Point number 1, we are transmitting samples from each and every signal. At given time instant, the switch will be connected to one specific input channel, and the sample from that channel will be transmitted over the communication channel. In the next time instant, the switch will move to the second input channel or the second signal. It will read a sample from that signal and transmit it over the communication channel, and this will keep on happening, and the switch will keep on moving across all the channels. It will go back to the first channel and will keep on doing so.